So today we're going to be looking at electrolysis, which is probably easiest by actually starting about what the word actually means. So electro to do with electricity and lysis breaking apart. This is something that works really well with ionic compounds because as they are ionic, they can move in a solution, move as a solution or as a liquid to be molten. So what we're going to be doing today is looking at a copper chloride solution. So CuCl2, which is aqueous. It's quite a concentrated solution. What we need to look at is what is actually going to be in our solution. So we're going to have, quite obviously, copper 2+ ions, from what we see there, and chloride ions. As well as that, because it's aqueous, we're also going to have hydronium ions, or I want to summarise that as H+, and we're going to have hydroxide ions. So those things will be all present. What we're going to be doing is using electricity to turn these, so turn this aqueous solution into its elements. Alright? So by causing redox to occur, we can affect a couple of these things that are in this. So if we were to look at what can happen with copper, copper can go to 1+ or it can go to its element. We're going to give it so much energy that it'll go all the way to its element. So if I look at the half equations that could occur, we've got Cu2+, which is aqueous, going to its element, which is a solid. Clearly the charges aren't balanced there, so we're going to be adding some electrons. Therefore, this is what we call a reduction reaction. Okay, the other way to look at it is it's going from a +2 oxidation state to 0. So it's being reduced. So this is going to be reduction. If reduction is occurring, then probably we're going to have oxidation occurring as well. Well, not probably, we are. So the chloride can actually be turned into its element as well, which is chlorine. And just a little note on that. When you do this, you're going to be putting a test tube over the top of this particular, what we call electrode, which is the sites where the electricity causes oxidation and reduction. I want you to put test tubes over those so that if it is the one that makes chlorine gas, it's not escaping into the air. Then we're going to take that chlorine gas over to the fume cupboard and test it with a thing called starch iodide paper, which will go black if it's a halogen in there. Alright? So this is clearly not balanced. 2 chlorines there, 1 chloride there, so 2 required. That also gives us a charge imbalance, so plus our 2 electrons. It's also possible that we're going to have some other reactions occurring. We may also have hydrogen turning into hydrogen gas, and we may also have, because this is what happens with electrolysis, hydroxide turning into oxygen gas. Alright, so we could have this as well. I'm not going to tell you if those happen or not. I'll wait for you to do the experiment to see if that is what's occurring. Alright, so what does it look like? Well, I'm going to do this very, very roughly. Hopefully it's clear enough for you to see. In our solution, which we'll have in here, our copper chloride solution, we have got 2 electrodes. And I'm going to draw them just as lines, but they really look like this. Alright, make sure they don't touch, because that kind of defeats the purpose. Because the solution itself can conduct electricity, it's ionic, that means that it completes the circuit. We then attach these to a power supply. And in case you can't remember, the big one's the plus, the little one's the minus. So that means this is going to get a positive charge here, this one will get a negative charge here. Which ions are going to be attracted to this one here, the positive one? The chlorides. Cool. So we would expect the one attached to the positive one to collect the chlorine gas. That's the one you must put a test tube over the top of. So we'd expect this to happen here. So at the positive terminal is oxidation or reduction occurring. Have a look at the half equations there. So at the positive electrode, we can see that oxidation is occurring. Cool. It's attracting the anions or cations, did we say? It's attracting the anions, okay? As part of what you do today, I want you to decide, is this the anode or the cathode? I'm not going to do that in this video, alright? That's part of what you're doing today, to determine whether this is called the anode or is it called the cathode. We're going to need to delete one of those two. Okay, we're going to need to delete one of those, whichever is correct. Okay, well everything's going to be opposites over here. So the negative electrode if oxidation is happening here, what would we expect is happening here? Reduction, very good. If this one attracts anions, it must be brave. Good. Attract cations. And whatever you choose this one to be, this will be the other one. So again, I'm going to put both words down. By the end of today, you need to know which one is which. So is this the anode or is it the cathode? Alright, so you need to delete one there. Okay. This is what is meant by an electrolytic cell. So that word might have confused you in the description of the achievement standard and in the description of this topic. So this is what's meant by electrolytic cells. We will use electricity to break apart an ionic compound back into its elements. It's how we often extract things like iron from its ores, like titanomagnetite and so on. It's part of the process of getting those things there. Aluminium from bauxite is another example of where this is done. It's also one way of getting sodium, where we can't have the solution, we have to have molten sodium salts, and then we can make the sodium metal from that. And that's one reason why it's so expensive. It's quite difficult to get. Alright, so you're going to do an experiment based on copper chloride, and from that, from your reading, I'd like you to determine which of these is called the anode and which of these is called the cathode. Alright, and I'll let you work out a way to remember that for yourselves. From here, we're going to be learning about electrochemical cells, which are the opposite to this, where we use a chemical reaction to generate electricity. Alright. And that's basically a quick overview of electrolysis and what you're going to be doing in today's experiment.